Algebra 2, this is section 2.6, example 3, the greatest integer function. Greatest integer function means that you want the greatest integer that is less than or equal to whatever is inside this double bracket. In this case, it's x. So we want the greatest integer that's less than or equal to x. So let's try some values here. So we've got, let's go x, and we've got our f of x. And we want to put some values down here. So let's start with something easy, 0. So if I put 0 in there, is 0 less than or equal to 0? That would be true. Okay, so 0 would be 0. What about if I'm at 0.1? Is 0 less than or equal to 0.1? What is the integer that is less than or equal to 0.1? Well, that would be 0. Let's move this down. Let's grab a number line up here. Throw a number line on here and take a look at it. If I'm at 0, I'm at -1, I'm at +1. 0.1 is right here. And the integer that is less than or equal to it, that's 0.1, would be 0. And same with 0.2 would be 0. 0.5 would be 0. 0.9 would still be 0. It would still come all the way back. We want the greatest integer that is less than or equal to that number. It's not until we get all the way to 1, and 1 would be less than or equal to 1. Likewise, we would have the decimals between that, so 1.5 would come back to 1, right? If I'm up at 1.5, 1.5, the greatest integer that is less than or equal to that would be 1. 1.9 would also come back to 1. It would not be until we get to 2 that we would have the greatest integer less than or equal to that would jump to 2. We've got some negatives we need to look at. Let me plot what we have so far, and then we'll come back and look at our negatives. So let me grab, I don't know, blue. So 0, 0 we have, 0, 0. And we know everything, so 0.1, 0.2, 0.5, 0.9, is all going to be 0, all the way until we get to 1. All of those values are going to be 0. And as soon as we get to 1, we jump up and we've got a point here. And now we know 1.1, 1.2, 1.3, 1.4, 1.5. Until we get to 2, we're going to be at 1. And then as soon as we get to 2, we jump up and we're at 2. Same thing, 2.1 would be 2, 2.2 would be 2, 2.3 would be 2, 2.4 would be 2, all the way until we get to 3. And at 3, we're going to jump up and be at 3. And we can keep going with that pattern. So these a little bit better. These are solid circles on the left, and they are open circles on the right. Okay, so what about negative? What if I am at a negative 0.1? If I'm at negative 0.1, then I am less than 0, right? So the greatest integer that would be less than or equal to this point would be negative 1. So that's going to go right here. Negative 1/2, let's put in there, that's going to be a negative 1. What if I'm at negative 1/2? Negative 1/2 is also back here, right? And the greatest integer less than that would be negative 1 again. So I'm still here. In fact, even whenever I get to negative 1, the greatest integer less than or equal to negative 1 is still negative 1. So I'm going to have all of these points here. But as soon as I get to 0, remember 0 was up at 0. So I have an open circle here on 0. And all these values get dropped down to negative 1. And this pattern is going to continue negative too. Now the positive side seems like it makes sense, but the negative side looks a little bit different. So let me value in it. So negative 0.5 goes to negative 1. Negative 3.5 though would go to negative 4. Because negative 4 would be the greatest integer that is less than negative 3.5. And so this is called a step function or a greatest integer function. And so it is in fact a function because I can move my line here, and my vertical line does not pass through any more than one point at a time because this open circle, closed circle is that's going on here, right? So it's a function. It looks like steps, so we sometimes call it a step function, but this one in specific is a greatest integer function.